All right, so we are starting, like I said, Unit 6. So we're going to start with Lesson 1, which is on angles. And radian measures. So everything we've talked about so far with angles has been in degrees. So now we're going to go from talking about things in terms of degrees to talking about them in what's called a radian. A radian. Okay? All right, so we're going to briefly talk about what it means to be a radian first off. Okay, a radian is derived from the unit circle. So the concept comes from the unit circle. All right, so does a degree. So we talked about a degree was 1/360th of a unit circle. Okay, the same thing is true with a radian, but a radian is a point xy on the unit circle if its distance from the origin is 1. So when we're talking about radians, a radian, 1 radian corresponds to 180 degrees. Okay, so when we're talking about radians, it's always going to have pi in the answer. Okay, it's always going to have pi in the answer. And to convert between degrees and radians, we use either pi equals 180 or 2 pi coordinates to 360. So we're talking about this in hemispheres. And what I mean by a hemisphere is it's half of a circle. Just like when we talk about hemispheres with there's a northern hemisphere and a southern hemisphere, the globe, it's the same concept. It's half of a unit circle. Okay, so when we're talking about radians, we are using the concept that 1 radian is equal to pi divided by 180. Okay? Okay? And if we're wanting to convert between degrees to radians, so if I'm starting in degrees and I want to go to radians, my conversion is I take my degrees times pi over 180, or your degrees times 2 pi over 360. Okay? Or in terms, so you can say that 1 radian is approximately, 1 degree, because we're starting in degrees here. 1 degree is approximately 0.017 radians. And how do we get that? We just take pi and divide it by 180 and find that decimal approximation. Okay? Now,
just take a degree times that 0.017 then?
You could, yeah, technically. Yeah. But you want to leave it in terms of pi.
Okay.
Like we want it in terms of pi, so that's why we just use pi over 180. Now, so that's one way. If I give something to you in radians, and again, radians is almost always going to have pi in it to some extent. If I want to go from radians to degrees, I take my radian measure times 180 over pi, or 360 over 2 pi. And again, it does not matter, because in all reality, they're the exact same thing. Are they not? 180 over pi, 360 over 2 pi. It's the same number. Okay? So, if we're working backwards, 1 radian is approximately 57.3 degrees. One radian is approximately 57.3 degrees. Which again, you can get by taking 180 and dividing by pi. Because pi is 3.14. Okay, and it all comes back to the equations for a circle. 2 pi r for circumference, pi r squared for area. That's also where that formula comes from. So when you talk about circumference, that's one rotation all the way around the circle, right? That's the perimeter of a circle. That's why that equation is 2 pi times radius. 2 pi is the radian angle measure all the way around a circle. Okay? All right, so let's try this. So if I have 330 degrees and I want to convert that to radians. 330 degrees, I want to convert that to radian.
Is it just the decimal value?
So what?
Just the decimal value? Or no?
I would use the pi over 180 personally. So I'm going to convert 330 degrees. What's my conversion from degrees to radians?
Pi over 180.
Pi over 180. Now, the way it helps me to remember it, for radians, I want pi in my answer. So I want pi on top. Whereas to go from radians to degrees, I don't want pi. So then I want pi on the bottom. Now, I see some of you are pulling out your calculators, which is fine, but it's going to give you a decimal answer, and I want an exact answer. So what we need to do here is just multiply straight across. Okay? Now we're going to simplify. These both end in 0, so we can divide by 10. 33 pi over 18. What do those both divide by? 3. I get 11 pi over 6. And that is in lowest terms. That is the answer I want. I don't want that as a decimal. Because I'm fairly confident you can all plug that into a calculator and tell me, well, 11 pi over 6 is 5.76 radians. I don't want that though, because that means nothing to me. I want it in exact terms. Okay, so you can use a calculator to help simplify the fraction, but I do not want you to just plug the entire problem into the calculator and give me 5.76. That will be wrong. I want 11 pi over 6. Okay? I want exact answers. All right, I'm going to give you another one, and I want you to try this one. Convert 120 to radians. Convert 120 degrees to radians. And again, I want it in lowest terms, so I do not want a decimal answer.
Wait, what's the tough one, Kyle?
Okay? What do we multiply by?
120.
Pi.
Pi over 180, right? So you get 120 pi over 180.
2 pi over 3.
Both end in 10 or a 0, so I divide by 10. Both are divisible by 6. So I get that that is 2 pi over 3. Now, what do you notice about the two values that I picked? 120 and 330.
They divide evenly.
Where are those both from?
The unit circle.
The
Unit circle. Unit circle. So, The thing about the unit circle is we talked about unit circle so far, everything we talked about is in degrees. Well, that's only part of the puzzle when it comes to the unit circle. And I said we would have to come back to it later to talk about the whole thing. Okay, well, we're at that point now. Okay, so what I'm going to do is we're going to quickly talk through all the values that are on the unit circle. So, we start. I would strongly suggest writing this down, yes. All right, so there are all of our values in degrees. Now, a couple of these probably fairly straightforward. 0 degrees, what do you think that is in radians?
0.
0. Okay? And we already said 0 is also 360. We already said 360 was what in radians? It's 2 pi. We said 1 full rotation on the unit circle is equal to 2 pi radians. And I know a lot of you are writing, so I'll give you a second. I'm sorry.
And 330 was 11.
11 pi over 6, right? Yep. Yep. And we're actually going to come back to those bow tie concepts. I'm not going to draw them on here today, but hopefully we remember what some of those, remember we talked about the 30-degree bow tie, the 45-degree bow tie, and the 60-degree bow tie. Those concepts are very helpful when it comes to radians as well. So now, again, when it comes to the unit circle, do I expect you to memorize it, the whole thing? I'd like you to. But again, can you derive it if you know the formula? Yeah. Like, could you go around and find every angle on here by just multiplying by pi over 180? Yes. Is that a huge waste of your time when you're looking for one specific number and you have to check over and over and over again? Probably. So it's helpful to just know these values. And this isn't something that happens overnight. Like, this is something we're going to have to study and look at multiple times. This is something you're going to work with from now through the rest of the school year. Okay? Like I said, trig to me is the most important part of this class. Trig to me is also the part on the ACT where a lot of you struggle. So that's where hopefully going through some of this will help you if you take the ACT coming up in either here in December or February or April. So hopefully some of this will help clear some of that up. So if we start with 30 degrees, how many 30s go into 180? 6. So 30 degrees is pi over 6. Is pi over 6. Because again, pi is 180 degrees. It's half a circle. Well, there's 6 of those in pi over 6. So 45. Well, how many 45s are there in 180? 1, 2, 3, 4. So 45 degrees is pi over 4. Using that same logic, what do we think 60 degrees is? How many 60s go into 180? There's 3, right? So this becomes, in radians, pi over 3. Does everyone see where those numbers came from, that first quadrant?
Got it.
Just taking 180 and dividing by those concepts. Okay? 90, as Jim said, well, there's 2 of those. So that's just pi over 2. Now that we have this, using those bow ties, we can figure out everything else. Okay? 120 fits which bow tie? 30, 45, or 60? 60. So, 60 degrees is 1 pi over 3. So that means 120 is 2 pi over 3. It's in the second quadrant.
Is that how it works?
Yep.
So
So you're just counting. So then, if I add 60 again, what's the next number that goes into that? 180, which is, we already said, that's pi, which is 3 pi over 3. We understand that?
240 before 5. 3 semi.
So 60, all right, let me explain again. 60 degrees is 1 pi over 3. I add 60. That gets me to 120, which is 2 pi over 3. You add 60 again. That gets you to 180, which is just pi because it's 3 pi over 3. If I add 60 again, where does that put me? 240. And how many 60s is that now? 4. So that makes this 4 pi over 3. Add 60 again. Where does that put me? 300, right? 240 plus 60 is 300. So that's going to be 5 pi over 3. And then 6 pi over 3 brings us back to 360. And 6 divided by 3 is just 2. Well, what did we just highlight? Well, those values are the 60-degree bow tie. Because you're counting by 60 degrees. Hence why we call it the 60-degree bow tie. Okay? Now, 2 pi is 360 degrees. Okay? Now we can do the same thing with pi over 4, the 45-degree bow tie. And what do we know about everything that's in the 45-degree bow tie? It should end in what? 5, right? Okay? I have 1 pi over 4, that's 45. 2 pi over 4, 45 plus 45 is 90, right? 2 pi over 4 simplifies pi over 2. I add 45 again. That brings me to 135. Well, how many 45s have I added so far? 3. So this is 3 pi over 4. If I add 45 again, that brings me to 180. 4 pi over 4 is just pi. Add 45 again. 225. Now how many 45s have I done? 5. Okay. Add 45 again. That's 270. And how many 45s is that? 6 pi over 4. And 6 over 4 simplifies to what? 3 over 2. So 270 is 3 pi over 2. Add 45 again. Where does that put me? 315. And how many 45s is that? 7. Add 45 again. 360. 8 pi over 4. 2 pi. Okay? So if you think of the unit circle like a pizza, it's all dependent on how many slices you want. So if it's pi over 4, that means I want 4 on each half, or a total of 8 slices. Okay? If it's pi over 3, I only want 6. If it's pi over 2, I only want 4. So what bow tie do we have left? Just the 30-degree bow tie. So if we start with the 30-degree bow tie, that starts at 30. That's pi over 6. Add 30 again. That's 60. 2 pi over 6, which simplifies to pi over 3. Add 30 again. 90. That's 3 pi over 6, or pi over 2. Add 30 again. 120. Or 2 pi over 3. Add 30 again. 150. How many 30s have we added? 5. So this is going to be 5 pi over 6. Because each 30 degree we add is pi over 6. Add 30 again, we're at 150. Or 180, I'm sorry. That's 6 pi over 6. Add 30 again, 210. Now how many is that? 7. 7 pi over 6. 30 again, that's 240. That's 8 pi over 6, which simplifies to 4 pi over 3. 30 again, that's 270. That's 9 of them, but 9 over 6 simplifies to 3 over 2. 30 again, that's 10. Well, 10 over 6 simplifies to 5 pi over 3. Add 30 again. Well, we're already at 11 pi over 6, which we just did a second ago. And if I add 30 again, it gets me to 12 pi over 6, which simplifies to 2 pi. So, if you look at this, 6, 4, 3, 2, 3, 4, 6. The bow ties are all the same. Okay, when you're doing radians, it goes 6, 4, 3, then there's a 2, and then it goes back up. 3, 4, 6. Then there's pi. Then again, 6, 4, 3, 2, 3, 4, 6. The denominator follows that same pattern every time. But again, to me, once I learned the bow ties, that helped me a ton. Because really, all I had to know was the first quadrant. And then I could just draw in my bow tie and I could figure out everything else. And again, on top of this, there's still the x and y coordinates. But we've already talked about that. That ratio does not change. And I can now give this to you in either radians or degrees and expect you to be able to give me that area or that value. So I could say sine of pi over 4 and expect you to be able to tell me that that's square root 2 over 2. Because pi over 4 coordinates to 45 degrees. What's the ratio at 45? Square root 2 over 2, square root 2 over 2. Sine is the y value. And we'll do more with that. But that's what we're going to be doing with that. Any questions as to how we found those values?
Yes.
Okay. So as I said, now we're going to practice with finding trig. So cosine of 4 pi over 3. Cosine of 4 pi over 3. So it only wants the cosine value. Only wants the cosine value, which is at x or y. Cosine is the x value. Remember, it goes alphabetical, cosine, sine. And 4 pi over 3 falls into what? 4 pi over 3 falls into what bow tie? 240. Right, it's 240 degrees. And 240 falls into what bow tie? The 60-degree bow tie, right? So we got to then figure out, okay, well, what is the value at cosine of 60, which is also cosine of pi over 3? Well, at 60 degrees, the xy coordinate that I gave you is half square root 3 over 2. So if I said to find cosine of 60 or cosine of pi over 3, which one of those numbers would I want? The half. Okay? So now, that's what it would be if it was in quadrant 1. But what quadrant is 240 degrees in? 3. And what do we know about quadrant 3?
Both negative, so it stays
They're both negative. So cosine of 4 pi over 3 then is negative 1/2.
Oh, yeah.
Because again, we come back to our rules. All students take calculus. All are positive in the first quadrant, only sine in the second, neither, only tan in the third, and only cosine in the fourth. So you find what bow tie goes in. You know that that xy value is going to be the same no matter what quadrant you're in. It's just a matter of whether it's positive or negative. Questions on that? How we did that?
You kind of lost me.
Yeah.
I'm sorry, but like
Like
that. Can we do another one?
Yeah.
Like you lost me so hard.
If you don't have your unit circle in front of you with your measures on it, you need to get that out. No, like the one with the XY values on it.
Okay.
Do you want us to rip it out?
No, I mean, you can. All right, let's try this one. Sine of 5 pi over 3. Sine of 5 pi over 3. So, 5 pi over 3 is what in degrees? Look at the circle we just made.
300.
It's 300, right?
60 still.
Yep. You're still in the 60-degree bow tie. So now we know since it's divided by 3 that it's in the 60-degree bow tie, which tells us we're still using that same xy coordinate. 1/2 square root 3 over 2. Because again, if it falls in the 60-degree bow tie, it's going to be this same xy value. It's just a matter of whether that value is positive or negative. So then we look at, all students take calculus. What quadrant are we in at 300? 4. And we want sine. Well, is sine positive or negative in quadrant 4? Negative. And what value up here do I want? The half or the square root of 3 over 2? So what do we think sine of 300 is? Excellent. Negative square root of 3 over 2.
Why did you want that one though?
Because sine is the y value. Cosine is always the x. Sine is the y.
Okay. I was not following that at all. Now I get what you're saying.
Things that are in each box.
So did that to me like
Sure.
this time, so I didn't understand
So,
now.
just to make sure we understand the bow ties. So if I have my 30-degree bow tie. 30-degree bow tie is 30 degrees, which is pi over 6. 150 degrees, which is 5 pi over 6. 210 degrees, which is 7 pi over 6. And 330 degrees, which is 11 pi over 6. Those are all the values 30 degrees away from the edge of your quadrant. The 45-degree bow tie is 45, 135, 225, and 315. Or everything over 4. So the 30-degree bow tie, all of those have values that are pi over 6. The 45-degree bow tie, all have values over 4. The 60-degree bow tie, we got 60, 120, 240, and 300 are all values over 3. 4 pi over 3 and 5 pi over 3. There are your bow ties. Uh, 4 pi over 3 and then 5 pi over 3. Yep. Now, so anything in the 30-degree bow tie is all going to follow square root 3 over 2, comma 1/2. Right? Anything in the 45 bow tie is going to be square root 2 over 2, square root 2 over 2. Either positive or negative. And then, as we found with the 60-degree bow tie, with the 2 examples we did, that's all going to be half square root 3 over 2. Then it's just a question of, is sine or cosine positive or negative in that quadrant? Does that help or no? Talking through that? All right, let's do one more example. One more. Sine of 7 pi over 6. Sine of 7 pi over 6. What bow tie does that fall into? The 30-degree bow tie. And we know that the 30-degree bow tie is pi over 6, or 30, is square root 3 over 2, comma, half. That's that bow tie value. That's the xy coordinates. So now it's a question of, okay, 7 pi over 6 is what in degrees? 210. Which is in what quadrant? The third. And since it's in quadrant 3, what do we know about the sine value? It's negative. So what is sine of 7 pi over 6? Negative 1/2. Excellent. Starting to get it now, hopefully? Okay. A little bit.
Is that what we're trying to find?
Yep, that's the value we want. Yep. Now, what if I give you something like this? What if I give you that?
Not today, buddy.
Because it went around.
You simplify that, don't you?
So this is,
You have to subtract.
so now instead of adding or subtracting 360, now what do you think we have to add or subtract? What is the radian equivalent of 360? 2 pi. So, if I have negative 19 pi over 6, well, that doesn't fit my unit circle. That means I've gone counterclockwise 2 times. Around, at least. So, to find this, we have to add 2 pi to this. And to add fractions, what do we have to have? Common what? And what's the common denominator between 1 and 6? 6.
3.
So that makes that 12 pi over 6. Because 12 divided by 6 is 2. So if I add negative 19 pi plus 12 pi, well, that's negative 7 pi over 6. I'm still negative. So what do I need to do again? I got to add 12 pi over 6 again. And what do I get now? 5 pi over 6, which is 150 degrees. But now again, So I've got tan. So this is equal to tan of 5 pi over 6. And 5 pi over 6 is 150 degrees. Well, since it's over 6, what bow tie does it fall into?
30.
Or 30. 30-degree bow tie follows square root 3 over 2 and 1/2, correct? 5 pi over 6 is in what quadrant? 2. It's in quadrant 2.
So the X is negative.
So the x is negative, the y is positive, correct? So we know that for tangent, we're working with
Both.
that value. But tan, how do we find tan?
Opposite over adjacent.
Which is sine divided by cosine. So we have to take the sine value and divide it by cosine. Well, what is sine, x or y? Y. Cosine is x. So it's half divided by negative square root 3 over 2. Just, we've got a fraction within a fraction. You can't leave that, so you have to multiply by the reciprocal of the bottom. And you, whatever you do to the bottom, you have to do to the top.
You wrote it back.
Go ahead. Yep, the reciprocal of the bottom. So we're flipping the bottom. Now, if I look at the bottom, those are all going to cancel. So that bottom is gone now. And the 2's can also cancel. So what do I get? 1 over negative square root 3.
But you can't have that.
But I can't have a radical on the bottom. So what do I have to multiply top and bottom by? 3. And I get an answer of negative square root 3 over 3. So tangent of negative 19 pi over 6 equates out to negative square root 3 over 3.
That was terrible.
That was real.